All right, superstars, again, compound inequalities. All right, this is the one that we've been leading up to. This is the high school presentation. Again, we're doing it at more of an 8th grade level, but it's in anticipation for what you're going to see. Mr. Daniels predicts around, I think, early October, maybe late September. So still relatively early in the year. Great news is, again, you're still using your solving equation skills, but our graphs have gotten a lot more complicated because it is a compound inequality. So our goal, our objective, again, is to solve and graph these compound inequalities. Good news is we're still working with one variable. Previous years, we have actually talked about double variables, and that definitely makes it a lot more complicated. All right, compound inequality. We've got two possibilities, and or. Now for the and, there's actually two ways that it can look. We're just going to go ahead and present one, which is a little bit more basic. And then or, there's really just one way it can be written. So for an and compound inequality, it says x is greater than negative 2 and x is less than or equal to 3. So if you notice that first one, x is greater than negative 2, so it's a open dot going to the right, and x is less than or equal to 3, that means it's a closed dot and going to the left. The more traditional way is a little bit easier for students to visualize it because the variable is going to be in between. And that's going to match up with the shading concept, that the shading actually has to be in between the two dots. But the true representation is what you see here. One's going to the right, one's going to the left. They're kind of going towards each other. And let's see. It'll look like this. Open on the left, closed on the right, and shaded in between. One of the possible solutions that you can have in there, because we may ask you to, you know what, pick a number, any number. Actually, not any number, because it's got to be in between those two. So negative 2 cannot be included because it doesn't have the equal sign. 3 can. Students may say 0, 1. A few students will say 1.999376. Again, trying to be annoying. But again, it's any number in between. So right there would be like a negative 1.3 or something like that. Ooh, negative 1.2, pretty close. But again, anything within the shading makes the statement true. For the or concept, it says negative 1 is greater than or equal to x. If you rewrite it, it says x is less than or equal to negative 1. Or x is greater than 2, which means open dot on 2, shading to the, I see the difference. Hopefully you do as well. On our most basic form for the and, you're going to have the shading in between. For the or, they're going to go opposite directions. Now, more advanced can have slightly different graphs. But again, we'll save that for your high school teacher. So we're going to try and show you the basic concept of solving and then graphing and or compound inequalities. If we were to choose one solution, remember positive 2 does not work because it's an open dot. Negative 1 can work because it's a closed dot. But you can pick it on the left or on the right. So let's see, 3, that is definitely going to be in the shading. You could have also said negative 3, negative 2. Anything within the shading is represented as a solution to the inequality. All right, give you just a moment for you to finish up that. All right, for this first part, like we talked about at the beginning of our inequality solving and graphing, was really working with the graphs. For it just says, write the compound inequality shown by the graph. Now your first thought should be, okay, it's not shaded in between, it's shaded opposite direction. So that should be, let's glance back here, and or, which one is it? Definitely going to be an or answer. So in our first one, it is a closed dot on negative 8. and it's going to the left. So that's why we have it written as x is less than or equal to negative 8. Go ahead and put the or word. I always tell my students go ahead and use big caps, capital O, capital R. Makes it a little bit easier to read and understand. And then look at the second dot. Notice how it's an open dot and shading to the right. Let's see. Yeah, x is greater than 0. It's not closed dot, so we don't have the equal part. Shading is going to the right. What numbers are greater than 0? 1, 2, 3. X is greater than 0. 1, 2, and 3 are greater than 0. Beautiful. On this one right here, notice that the shading is in between the two dots. So that kind of gives you a hint that it's going to be an and problem. And again, there's two ways to write it. I like saying, okay, x is in between because that's where the shading is. Our solution to the inequality is in between. Well, I got the number on the left, negative 2. We always want the smaller number on the left for our and compound inequalities. Larger number on the right, which is represented as a 5. And we just go to make our correct inequality symbols. Negative 2 is less than x is less than 5, which means x is greater than negative 2, but x is also less than 5. And that's what the graph is represented there. X is in between. The shading is in between. Both of them are open dots, which is why we do not have the equal part at all. All right, see if you need to do any extra writing there. And again, we're just going to do a few problems and then look at the assignment. Just do a few together, and then you'll be able to work on your own. All right, let's see here. Okay, solve and graph the compound inequality. Oh, we gave you one that's way too easy. And then again, after you graph it, give one solution that satisfies the compound inequality. So the way we solve it is we look at the center. If you notice, it's just a simple x plus 1. Now, if it was a 2x plus 1 or even some fraction involved, a little bit more complicated, but a nice traditional x plus 1. So starting in the center, go ahead and write subtract 1 underneath the plus 1. And then we're also going to do that on the left side. So put a subtract 1 underneath the negative 5. And then again, a subtract 1 underneath the positive 2. So it looks like this in the middle, left, and right. And if we clean it up, it now looks like this. Negative 6 is less than x is less than 1. We don't have to do any division or multiplication because x is already isolated there in the center. All right, so for our compound and inequality, we're going to go ahead and make a quick number line. We've got two important dots, negative 6 and positive 1. We notice that both of them are not going to contain the equal sign or equal part, so therefore they are both open dots. You can put some extra number there if you'd like to. Most students just kind of put both numbers there. And then we're going to go ahead and shade. And if you remember, the X is in between, so the shading is in between. Now that you're looking at your shading, go ahead and put a number down. You've got a lot to choose from. That is in the graph, meaning the shaded part. The instructions are very specific. Give one solution that satisfies the compound inequality. So a lot of students might say 0 because 0 is definitely in between negative 6 and 1. Some might contain a fraction. Negative 3 is definitely there as well. 1 cannot be included because it's not equal. Negative 6 cannot be included. You can use a decimal or a fraction. I personally like 0. Negative 3 is definitely good still. But again, this is an and compound inequality. Ooh, this one looks a lot better, a lot better. All right, starting in the center again. On our previous one, it had a plus 1, so our inverse operation was subtract 1. On this one, it says subtract 1, so our inverse operation is add 1. Both sides. Let's see. All right, add 1, add 1. Oh, very nice. So looking at the left, 8 plus 1 is a simple 9. In the middle, you're just going to have a nice 3x. And then on the right side, 12. So again, it's the same skills. We're just showing it in the middle, left and right. So since it's the same skills, let's go ahead and look at the middle, which says 3x. So we need to divide in the middle, left and right. If we fully simplify it, it now looks like this. 3 is less than x is less than or equal to 4. Now, this graph is going to be having less possible easy numbers to find a solution that satisfies the compound inequality. Because when we graph it, again, we have an open dot on 3, a closed dot on 4, and then one more time, we shade in between because x is in between. So to find one solution in between, it has to be, well, can't include 3. We can include 4 if we want, but most likely you will choose a decimal or a fraction answer. So one solution may be like 3.5. Oh, 3.2. That's pretty close, pretty close. We're going to go and look at our OR problems next. Solve and graph the compound inequality. If you notice, it's clearly an OR problem because the OR is presented to you. Our goal again is to isolate the variables. So if you notice the first one, it says 8 plus t. So I'm going to go ahead and subtract 8 both sides. T stays as it is. So t is greater than or equal to 7 subtract 8. Well, that's negative 1. Put the OR part of your answer, part of your statement in the middle. And then same thing over here, negative 8. So, or sorry, subtract 8 both sides. So t is less than negative 6. So no division, multiplication required there. So we're going to go ahead and jump right to our inequality graphing. Now, remember, we want the smaller number on the left. So you got a negative 1 and a negative 6. So our smaller number is negative 6. Our larger number is negative 1. On the negative 6, you have an open dot, and it appears, it says t is less than negative 6, so that's definitely to the left. And you have a closed dot on the negative 1. It says t is greater than or equal to negative 1, greater than is 0, and the positives, which are all to the right. So notice again how the in-between is not shaded. But not to say that that can never occur on an OR problem, because again, you might have some really advanced ones in high school, but just for right now, we're keeping it as nice and neat at the 8th grade level, introduction to the high school compound inequalities. So if we were to pick a solution from this compound inequality, I would like 0 again, because that would be on the far right, because it is greater than negative 1. If you wanted to go on the left side, so less than negative 6, maybe negative 10, something like that. All right, go ahead and solve these two quick inequalities. And that's kind of what you're going to notice on the OR problems. They're really just two separate inequalities. But when you graph them, it is one complete compound inequality. All right, you got about 30-second head start. About 10 more seconds, quick head start. Again, two separate little inequalities for you to solve. So on the first one, did you multiply or divide? We divide both sides by 4. Now remember, if we were to divide both sides by negative 4, we would have to reverse your inequality sign. But it's just a nice basic 4? On the second one, did you multiply or divide? Put your word or in the middle. A lot of students forget that, and that is required for your statement, so please be careful there. And then if you divide, x is greater than 7. So when you're ready, quick number line graph, please. Remember, smaller number on the left, so 5. Larger number on the right, 7. Then we decide on what type of dots we're going to have. So if you notice, again, it's the exact same skills from earlier in the weeks dealing with inequalities. So on the 5, you have a closed dot. On the 7, you have an open dot. On the 5, which direction is your shading? On the 7, which direction is your shading? So those are your thoughts. Very nice. So again, if we wanted to pick a solution to our compound inequality, it could not contain any numbers in between, so it can't be like a 6. But it can be less than or equal to 5, so maybe like a 4 or even 0. Or it can be greater than 7, like a 10, a 1 million, things like that. All right, let you finish anything up, and then we're going to work on the worksheet. So go ahead and pause the video so you can pass out the worksheet, please. All right, welcome back. Let me see if I can get my Cami up and running here. Let's see. Like a basic inequalities, compound inequalities. Let's see if we can find some more challenging ones. Were we too nice for you? Oh my goodness, these ones are not too difficult at all. All right, let's go ahead and do number 17 and then maybe number 20. All right, for number 17, again, start in the center. This is definitely an and problem, so be careful with that when you are doing your graphing. So let's see, add 3 from the middle, left, and right. I always do it in that order, middle, left, right. So we're going to go ahead and say 5 plus 3 is 8, is less than or equal to 4b, less than or equal to 12. Back to the center, the middle, divide by 4, middle, left, and right. So 2 is less than or equal to simple b, less than or equal to simple 3. If you notice, they are both equal to, which means when we make our number line graph, again, most students on these compound will just put smaller number, larger number. Both are closed. Let's change the color. And again, both are closed. And then our shading, since a B is in between, the variable's in between, we're definitely going to shade in between. You can go in and connect it with a highlighter, a second color, or shade it a little bit darker with your pencil. So a solution to this compound inequality can include 2, 3, or anything in between the two. So fractions, decimals, roots, any type of real number between 2 and 3. All right, look at number 20. Number 20, again, is really just 2 separate problems. So I'm going to go ahead and see if I can space them out a little bit better. So I'm going to say 2a subtract 5 is less than negative 5. We got our or, and then 3a subtract 2 is greater than 1. So again, just 2 separate problems. Let's add 5 both sides. I want this to look more like a plus sign. So 2a is less than, well, negative 5 plus 5 is 0. Divide by 2. So a is less than 0. Put the or there. So again, it's really just solve one, solve the other. You're going to learn later on in high school when you're dealing with compound inequalities, you're going to have more complicated ones dealing with absolute value. And it really is just set it up as an and, maybe an or problem. But again, it all comes back to just your solving skills. 1 plus 2 is 3. Remember, we've said since the beginning of the year that solving equations or now solving inequalities is the most important skill that we can help you achieve before you move on to high school, which is another reason we are practicing solving. All right, quick graph. Smaller number on the left, which is 0, larger number on the right, which is 1. According to this, they are both open dots. A is less than 0. So again, we're not going to shade in between. A is less than 0, which means we shade to the left. A is greater than 1, which means we shade to the right. No shading in between. If we were to choose a solution to this compound inequality, again, it could not include 0 or 1 because they do not have the equal part. They are open dots. Less than 0 could be -1, -2, fractions or decimals. A is greater than 1 could be 2, 3, 10. Fractions and decimals are also included. So again, great news is a lot of this stuff you already know how to do, just small extra pieces here and there to get you ready for high school. All right, be awesome. Continue to be awesome. Got a few more days of this year. You can do it.